Hey guys, Mr. Milton here. Today we're looking at multiplying and dividing by monomial notes. At the end of this video, you should be able to multiply a polynomial by a monomial, and you should be able to find the GCF of a polynomial and divide or factor it out of a polynomial. Okay. Recall that when we simplify 5x cubed plus 2x cubed, we added these together, 5 and 2 because they're like terms, 7, and we kept it as x cubed because our rule with addition is they have to be the same. And our rule of thumb is, if they have to be the same, they have to stay the same. Okay, so what operation is being used here? It's addition. And our exponents don't change. Now from our exponents chapter, we've already done something like this, a to the 4th times a squared. Remember that we did, okay, that's a to the 4 plus 2, a to the 6th power. What operation is being done here? Not addition, right? It's multiplication. And do the exponents change? Yes. When adding or subtracting terms, the exponents don't change. But in multiplication or division, the exponent does change. Okay. So here it says multiply each monomial into the polynomial. And so we're just distributing this. 3 times x squared, 3x squared. 3 times 4x, 3 times 4, 12x. 3 times negative 5, negative 15. Okay, easy enough. We're distributing a constant. Not too much to think about. But maybe we're distributing something with a little bit more. So we got 4b times 5b squared. 4 times 5 is 20. B times b squared will give us b to the 3rd. We've got 4b minus b. So 4b and negative b. That gives us negative 4b squared. And then we have 4b times 1, which is just 4b. Don't want to overcomplicate that. Choose a different color as my writing might get close to each other. All right, we have 7h to the 3rd times 3h to the 4th plus 2h. So as we do this grouping again, 7h to the 3rd, 3h to the 4th. Okay, that gives us 7 times 3, 21. H to the 3rd, h to the 4th, h to the 7th. So 21, h to the 7th, getting to use our exponent rules. 7h to the 3rd times 2h. 7 times 2 is 14. H to the 4th. All right, because that exponent here is 1. 3 plus 1 is 4. All right, and that's that. And then finally here, we have 2ab cubed times 4a squared b minus 5b. All that grouping. 2 times 4 is 8. A times a squared is a to the 3rd. B to the 3rd times b gives us b to the 4th. Minus 2 times 5 is 10. A, there's no a over here, so it just stays a. B to the 3rd, b to the 4th, b to the 7th. All right, and that's just distributing. Okay, we have to make sure that we're keeping our numbers together and our exponents in check, but it's our exponent rules and it's multiplication and it's being organized. You'll notice, let me do this before I go too far ahead, that we don't have like terms after we've multiplied. Think about it, if they're not like terms before we multiply by something, they won't be like terms afterwards. So that's a common mistake that a lot of people will make, is that I'll see a problem like this, and then I'll get an answer of 0, because it's like 3 plus 12 is 15 minus 15. They'll say like x squared, okay, or x to the 3rd. Okay, these are not like terms. We already did that with addition and subtraction. They need to be like terms for us to simplify anymore. Okay. All right. All from 4th grade, listing our factors. So we're going to talk about factoring here. List the factors of 36. Factors, remember, those are numbers that multiply to give us 36. So if you think about it, like 1 times 36, 2 and 18, 3 and 12, 4 and 9, and then 5, 6, and 6. Okay, and so factors are just numbers that multiply into our number. Okay, a lot of times we won't really consider 1 as a factor, but we'll keep it there for that. Okay, so here it says find the GCF of 12 and 18. Remember, GCF stands for greatest common factor, the largest number that's a factor of both. Okay, so as we look at 12 and 18, a couple things we can do here, but you can look at 12 and 18 separately and be like, okay, well, what goes into 12? 1, 12, 2, 6, 3, 4. You do the same thing with 18, 1, 18, 2, 9, 3, 6. You say, okay, what's the largest number that fits into both? And the answer is 6. 6 is our GCF. Okay. The other way you can do this, and this might be like you kind of do mental math. The other way you can do that is you can list out the factors of 12 and 18 and say, okay, what's our factorization of 12 and 18? It'd be like, okay, 2 times 2 times 3. For 18, it would be 3 times 3 times 2. All right, and then you say, okay, what goes into both of these? Well, 3 and 2. There's a 3 and there's 2 in both of these. 3 times 2 is 6. Ends up getting 6 either way. Okay. So that second method might be a little bit better for a problem like this because we don't want to list out all the x's and possibilities that way. And so for this problem, we might look at it and say, okay, 4x cubed, what goes into 4? 4 gets broken down to 2 and 2. X cubed, there's x times x times x. 12x squared. So 12 is 2 times 2 times 3. X squared. There's 2 of them. 8x. 2 times 2 times 2x. Okay, so as we look at this listing, we'll say, okay, what do all these have in common? So they all have 2 2s. Ballerinas. Okay, and they all have an x. So what's our greatest common factor? What's the thing that goes into all of these? 2x. Now, do I have to do this listing the factors out? No. If you look at 4, 12, and 8, and you're like, 4 goes in all of that. That works. I would look at it and look at my exponents and say, okay, what is the lowest exponent I have? Because that's my common factor, x to the first power. So 2x to the fourth. I said 2. I said 4 like multiple times. I wrote 2 anyway. Okay. 2 times 2 is 4. Right. Okay. All right. So you might look at 4, 12, and 8 and say, hey, 4 goes in all of these. That's my GCF between those. X cubed, x squared, x to the first power. What's my lowest exponent? 1. I choose the lowest one because I need to find the number that goes into everything. All right. Here it says find the GCF of each polynomial. So they're only asking us for the GCF. Okay, so as I go through, I'm going to look at my numbers. 4, 10, 14. What goes into each of these numbers? Okay, 4, 10, and 14, 2. Okay, because even though these are, they're all even, this is 2 and 5, 2 and 7, 2 and 2. So 2 is my GCF between 4, 10, and 14. Okay, and then you look at the x's, the lowest exponent is 3. So 2x cubed is my GCF. Okay, all it's asking me to do is find the GCF. All right, between 3t squared and negative 18, 3 goes into 18 and 3 has to be the GCF. There's a t squared here, but there's no variable in the second one at all. So my GCF is just 3. And then as I look at number 3, I have 4, 6, and 3. So there's 4 and 6 are even, but 3 is not. 3 goes into 6, but not in 4. So as we look at what goes into all of our numbers, 1. Okay, and then what's our lowest exponent? We don't have, I guess we could say x to the 0. So it's just like 1 times 1. Our GCF is 1. Which basically means like, hey, we can't factor out anything meaningful. Okay, GCF is 1. That's as good as we can go. Okay, finding the GCF, though, is only the first step in factoring polynomials by binomial. The second step is dividing each term by the GCF. Okay, so let's do a few problems, where we are actually factoring out the monomial. Okay, and what we do, what it looks like after we're done factoring out a monomial is like the start of a distribution problem. So when I look here, I have 6, 12, 9. What goes in all those? 3. I have x cubed, x squared, x to the first. 3x is my GCF. So 3x is my GCF. So look, I'm going to take 3x from each of these. Okay, so as I write and factor out my number, I have my GCF on the outside, and then the quotient of my GCF and what's from in the inside. So 6 divided by 3 is 2. X cubed divided by x to the first, x squared. 12 divided by 3, -4. X squared, x to the first, x. 9 divided by 3 is 3. X divided by x cancels out. And here's what we have. Okay. Looking at problem number 2, we have 8 and 12. What goes in both of those? 4. We have x to the 5th and x squared. 2 is the lower of the 2, and it means both of them have it, so we're good. So 4x squared is what I'm dividing both of these by. Okay. I want to make sure that I put my GCF as part of my final answer here. Outside. 8 divided by 4 is 2. X to the 5th divided by x squared is x to the 3rd power. -12 divided by 4 is 3. X squared cancels out. Okay. Here we have 5d cubed plus 20. 5 goes into both of these. Okay. 5, my GCF. Okay, and so I have d cubed plus 4. Notice that we didn't really look at d because there's no variable in the second one. Can't take d out of 5d cubed if there's no d in 20. Number 4, as we look through 2, 5, 6. Okay, so 2 goes into 2 and 6, but 5 doesn't, so not really dealing with numbers there. X to the 4th, x to the 3rd, x squared, they all have x's, so x squared is our GCF. And then once we take that out, we have 2x squared, 5x, and then minus 6. All right. We can always check and double check to make sure that we're good and that we've taken out the GCF, because inside of our parentheses, we shouldn't have any common factors between all three of them. Okay, so there shouldn't be anything left that we're like, oh, we can still take this out. Okay. Number 5, as we look and look for GCF, there's x in this one and x in this one, but not in the last one. There's 9 and 8, not even close. Okay, so here, there's nothing we can do to factor this by just taking the GCF out. Okay, we'll actually look into factoring quadratics like this later on in this chapter. But right now, we can't factor anything out. Okay, and then this last one, 6, 12, 18, they all have 6. Okay, p to the 5th, p to the 4th, p to the 3rd, they all have p cubed. Okay, and so now I have 6p, oops, that was a funky p. 6p cubed, that leaves me with p squared plus 2p minus 3. The p's cancel out here, so we don't have a variable. All right, and so that, my friends, is multiplying and dividing by a monomial. All right, see ya.